Hey there, my name is Alejandro. I woke back for day 357 of me doing a daily LeetCode challenge after I reached 1 year's worth of green contributions here on GitHub. So today's runs for July 8th, 2025. And without further ado, let's get straight into it. Okay, let's see what problem. Okay, today we get a LeetCode hard. That's going to be fun. Okay, so for context, I did do my ACL reconstruction surgery. I don't know how much I'll be able to show on the camera. But this is my current leg at the moment. I have this little thing right over here for elevation. On the TV I was playing Lego City Undercover to essentially pass the time. But yeah, this is my current leg as it is. They basically it's hard for me to see what's going on inside of the camera. But basically they took like part of my patellar tendon bone here to essentially reconstruct my ACL. Super cool stuff. And yeah, so now it's like I'm stuck on the couch and so on. So if anything, good thing we get a LeetCode hard. Well, I have the time to invest into this thing, right? Okay, I see maximum number of events that can be attended to. Also, it's probably going to be a continuation to yesterday's problem. And, 60%. Okay, so this is not a bad acceptance rate. Okay, you're given an array of events where events of I is equal to start I and I value I. The ith event starts at start day and ends at end day I. If you attend this event, you will receive a value of value. You're also given an integer k, which represents the maximum number of events you can attend. Okay, you can only attend one event at a time. If you choose to attend an event, you must attend the entire event. Note that the end day is inclusive. That is, you cannot attend two events where one of them starts and the other ends on the same day. Return the maximum sum of values you can receive by attending events. Okay, so really you're going to try to care about events in terms of start times and times and values, yeah. So here 4, 3, and 1. Yeah, this is just a regular scheduling problem. We've seen this type of things where it's maximum number of non-overlapping intervals, except this time. So yeah, I've solved the problem like maximum number of non-overlapping intervals in my advanced algorithms course. That algorithm was a greedy algorithm where you sorted them all by n time or something like that. However, the value of that problem is the number of intervals you're able to fit, right? So it's like here, you like the two greens because here you're able to fit into two intervals versus if you pick the red one, you can only fit in one, right? So here the reward function is different in that it's not necessarily the maximum number of intervals you can grab, it's the maximum value where each interval has a certain amount of weight. So that changes the problem and probably in a way that makes it a little harder. And we're also given some cap k in terms of the maximum number of intervals we're able to accept in the first place. Okay. So, I mean, we could do something like events.sort. I think that's going to be something that's very useful for now. Events equal, and yeah, and sorry, just because it's like, for that greedy problem, yeah, so return maximum sum of values can receive by attending the events. So if it's like a typical scheduling problem, then there's going to be a very greedy aspect to this problem. Yeah, so here's like you can't take that. Yeah, here you'd rather take that one because it has better weight, right? Oh, so is this going to be like dynamic programming where it's like you have the sorted intervals? And then, it's going to be DP where we have like the sorted intervals, and then we can either choose to pick an interval or not, right? If we choose an interval, we go to that end time and so on. What are the constraints? I have to make it linear. Okay, this is a LeetCode hard at the end of the day. Okay. Yeah. Maybe it's like one of those DP problems where it's like I point to the next best one, and then like I form a solution with all the best ones, and I just take the top k out of those. Although the fact that I can only take up to k intervals might start messing up the problem. Right, because I could do it based off k and n and I. Yeah, okay. 60% acceptance rate is unusually high. That would suggest that the problem is not that hard. Or maybe accepted should be a better queue for the future. Oh shoot, it's, sorry, my leg's kinda itchy. Yeah, okay. Dude, I can't believe, like, this is nice. Like, this is day one of surgery. It's like I'll have a forever video recording of me, like, hours after the surgery. It's like me right now. I'm like, I'm chilling. I still have. Ooh, okay, yeah. I should probably not show the MRN. It's like, here you go. Well, okay, well, I guess that's my physician's name, Dr. Taranati. Whoops. Did not mean to dox you there. But yeah. Yeah, cool stuff. Yeah, so it's gonna be some aspect. Well, okay. So it's not gonna be DP because DP is gonna be right. I can write like a DP solution. It's just gonna be based off I and K. It's gonna be like O of a length of events times K. Whereas like if K is up to events dot length, like I can't do a. Oh, O of K times events dot length is less than or equal to 10 to the 6. Okay, so we can do DP. Ahaha. Okay. Well, that's the biggest hint I needed of my entire life. Okay. Self.events is equal to events. Self.k. Okay. Return. Yeah, we'll just do that. For now, we'll just use a cache decorator. And we'll say k equals 0 or I greater or equal to n. Right, if we have no more events, or we've picked the max amount of events, then we will return 0 as in 0 remaining value. Otherwise, we'll say event is equal to events of I start, end. I guess I really don't care about the start part. For now, we'll keep it, but yeah, eventually we'll probably get rid of that. Wait, we sorted by start times. Yeah, we're gonna say this one, pick current event. Actually, this will be start event, value, pick current event. In this case, value points, but can only do events. Plus 1. Oh. Yeah, DP is not going to work here, right? Because I'm going to need some kind of... Yeah, DP is not going to work here because of that. Case 1 is going to result of DP of I. This one. Right, like value plus of DP. Case 2, skip current events. Well, actually here we'll say is there do in Python? Do? No. Here we'll say start comma and make value 0, 1, 2. Here we'll make this case 2. Here we'll say case 1. Skip current event. Case 1 is equal to subject TP of I plus 1. I skip current event and just move on with still k elements remaining. Case 2. We need to find the first event. Yeah. Survive starts is less than or equal to end. Well, it's not the case. This is greater than. I less than or equal to n. I less than n, and this. Return max of case 1, case 2, something like this. No, really. What? Oh, we were going to do I. Yeah, that's accepted. Submit? Is that it? Bruh, completion streak 357 days, consistency is key. See you tomorrow. I think that's the easiest LeetCode hard I've ever done in my entire life. Like, okay, maybe it should be a medium. Like, low-key, I could see this being a LeetCode easy. Okay, maybe not a LeetCode easy. Maybe that's a bit of a stretch, but this should not be any harder than a LeetCode medium. Okay, well, I see why there's a high acceptance rate now. Yeah, this is not a necessarily difficult problem. Well, sweet. Here we'll just say self.events, self.memo. Let's pull that. Events, memo. If I in self.memo, return self.memo of I. Res equals case 1 if case 1 greater than case 2, else case 2. So the max of them 2. Self.memo of I, k. Oh my gosh. Ooh. Index equals I plus 1. Well, index less than n and events of index. Index plus equal to 1. Index. We could also do some binary searching here. I don't know if that'll make things faster. Sorted events. There we go. No. Res, return res, and like this. Sweet. Yeah, I might be able to do, okay, well, first let's submit this and see how much faster it is. Oh, this is going to be wrong, this is going to be wrong, this is going to be wrong, I need IK. I need IK here. Yep. Okay, so yeah, so now we're a lot faster when the standard deviation curve. Ooh, and I see there's another one, right? So here I wonder if we can do binary search. Find leftmost index, which this is the case. L comma R is equal to I plus 1 comma N. we'll say L less than or equal to R. Mid is equal to L plus R over 2. Mid start greater than end. This minus 1 in that case. Over potentially valid intervals. Yeah, this I expect to fail at some point. Yeah. So now this should pass. Leftmost. No, I got it wrong. Oh, did I do, here we picked the thing, yeah, so here we do value plus the guy. Yeah, so that works. So now we have an aspect of binary search instead of linearness. Oh my, that actually made things a lot slower. Really interesting. I guess, like, you know, I might only go at, like, by doing it the other way, I'll end up doing at most one O of n sweep, right? Versus the other one, I end up binary searching through the. Okay, yeah, fine. All right, then we'll just keep it there. At least we tried the binary search way. Sometimes simple is better. Sometimes I want to check something. Can I just do assert leftmost equals L? Okay, that's cool. That's cool. So here I could just do L. That would have worked totally fine. Okay, so we're not going to do it the binary search way. That's totally fine. We'll end up only doing one O of n total sweep with the other way anyway, which is like very efficient anyways. So I do not mind. Invalid. Okay, now I wonder if we can minimize some space. Do we use start? No, we don't. We do use end. Yeah.
Can I go bolder?
Go ahead, go for it. Yeah. And comma. Value in this. And that way I can just do this. This would be 0. I do need each interval start time. I just don't need the current ones. So we'll just do that. Yeah, that's fine. Okay, I mean, we have a nice and working solution. There we go. There we go, sweet. 887 ms, beat 60.44%. Maybe there's a better way of doing things, but there we go, bada bing, bada boo. Okay, so nevertheless, as always on my videos, I do a quick recap of ISO solid problems. For this one, essentially, the very first thing that came into my mind after reading the problem was DP, and I was indeed right about that, right? I automatically realized a way that I could do it in of length of events times k. However, by reading this, I thought that, like, you know, it said k comma events.length are each up to 10 to the 6. So I was like, oh, okay, I won't be able to multiply them. But then, like, less than 5 minutes into the video, I realized it was saying k times events.length, and that was like the only hint I needed in the world, right? Then I was like, okay, I already have a DP idea and how to solve it in less time complexity. 10 to the 6 is allowed on LeetCode. I'm just gonna roll with this thing, right? So the way I did it is, very first thing is I sort the events. So this problem says, this is like very close to a similar scheduling problem. Essentially, you want to grab the highest value. So each interval has a value, right? So like, for example, this one has value of 4. It goes from 0 to 2, right? Or from 1 to 2. Then this one goes from 3 to 4 and is a value 3. This one goes from 2 to 3 and is a value 1, right? And so you want to grab only non-overlapping intervals, right? So for example, this interval over here and this interval over here are non-overlapping. That's why we can do a value of 7 because 4 plus 3. But we can only do non-overlapping intervals. So like, for example, we can't pick this one because, like, you know, it's overlapping with this one and this one, right? And if we pick this one, then we can't pick this one and we can't pick this one. So that would give us a result of 1. And we want the highest possible value we can get. Now, the only other restriction is that we're also given an integer k, which is the maximum number of intervals we can grab, right? If there was another interval over here, right, that's not overlapping with these two, but since k is equal to 2 and its value is, like, let's say 2, then we can't grab it, right? Because these two are bigger in value, but we can't grab any more than 2 intervals, right? So like, here's a good example. K is equal to 3. Ideally, these are all non-overlapping intervals, but we can't grab this one with the smallest value just because it's like we can only grab at most 3 intervals, so we might grab the 3 that are biggest over here because they're all non-overlapping, right? So that's kind of the idea for this problem. And so what I said is, like, okay, first, interval problems, there's almost always 2 ways to solve them. One is, like, either you sort them, and usually you do something greedy. I guess this time I did dynamic programming, but sorting is usually a good technique. And the other good technique I usually use is line sweep. But almost, like, I don't know if I've ever gone through an interval problem where I didn't have to either rely on sorting, some heap, which when I say heap, like, you know, it's like basically the same idea as sorting, right? There's going to be some getting in the elements in some order, right, from minimum to largest, or either sorting heap or the line sweep algorithm, right? Usually one of those patterns is, like, applicable to 99.9% plus of interval problems, right? And this problem was no exception. Very first thing that I did was sort all the events by their start times so that I have them in essentially linear fashion, right? Because what the idea is going to be is I'm going to go through all the events from left to right, and for each event I'm going to say, okay, there's 2 cases. Either I keep the current event or I don't keep the current event, right? Which is why I immediately thought of dynamic programming, where it's like, okay, if I do keep the event, then that means it's like, okay, I can only do one event in, like, a single time slot. I can't do any overlapping things, which means if I pick an event, I must only pick new intervals whose start time is bigger than the current event I just picked end time, right? But I get to add that event's value. Otherwise, if I can either, again, grab an event, in which case if I do, it's like, okay, I grab the event, get its value, and move on to after that event's end time. Or otherwise, I can choose to skip the event, and if I skip the event, then there's no restrictions, but I don't get any added value to my sum. So this is literally what I did. I have a DP function that takes an index I, because we're going to go through every single interval in events, index by index, and for each one we're going to say, okay, do we keep it or do we skip it, right? Which is what DP is good for. However, I also take in another parameter k because I note the fact that we can only have at most k intervals, right? So I'm going to essentially have an integer k that essentially tells me, hey, what's the maximum number of intervals I can take left? Because at any time I pick an interval, I'm going to subtract k by 1. At any point, if I get to k is equal to 0, I'm going to say, okay, I cannot pick any more intervals, so return 0. So let's look at this DP function. Okay, very first thing is, like, I have a cache, right? So self.memo is a dictionary, so, like, you know, given any input ik, if ik has already been computed in the past in my self.memo, then return self.memo of ik. At the end of the function, I'll say, okay, whenever I get a result, self.memo of ik is equal to that result, return rest. That way, if I ever come across it again, it's already cached, right? Okay, so that's out of the way, which means that the total number of subproblems will be, like, you know, the total number of i's, which is the number of indices and events, right? So O of n, where n is the length of events, times the number of possible k's, right? We're just going to go from 0 all the way up to the original value of k itself. So it's like, the value of k times the length of events will be the maximum number of operations, because everything otherwise inside of the DP function is O of 1, right? Like this is O of 1, O of 1, O of 1, O of 1. Recursive calls, we count them as O of 1 because we assume we do every single one. This looks like a while true loop. Essentially, this index value will be based off the current index I. In total, I'll only end up like looping through the entire events array once, right? So even though it looks like an O of n loop inside of here, in total, I'll only ever go through the entire thing once, right? Or at least for each k. But again, even if I only go through it once for each k, it's O of n work for each value of k, 0, 1, 2, 3, and so on. So it's n times k, right? So it's like n times k subproblems. In total, for each unique k, I might end up doing a total of n O of n work. So it's like O of n times k plus O of n times k is equal to O of n times k, right? And here we're told n, where events.length, times k is less than or equal to 10 to the 6. So we are in bounds for this solution, right? But our solution is literally O of k times events.length. Okay, enough yip-yapping. So first we cache. All right, so let's get events, which is equal to start.events from up here, which is the sorted events by start time, and then end time and value, blah, blah, blah. Then we're going to say, okay, n is equal to length of events. Start and value is like, okay, these events have 3 elements each. They're going to be start, end, and value. So that's just what I call them. These are the indices, right? Start is at index 0, end is at index 1, value is at index 2, just to make my life easy. Okay, our very first base case. If k is equal to 0, what does this mean? We can't pick any more intervals because we've used up we've picked k intervals, so we return 0 to denote 0 more value can be added, right? Or if I is greater than or equal to n, that means we're past the end of the array events, right? Our current index I is past the end of events, so there's no more events left for us to pick, so we return 0. We don't return float of infinity if k doesn't equal 0, because remember, we can pick at most k events, but we don't have to pick k events. We can pick k or less events if we really wanted to, right? Maybe some of the events are negative value. Okay, I guess there's no negative value events, so okay, whatever. But we only have to pick at most k events, right? If we wanted to enforce to pick exactly k events, right? Then we could say like, return 0 if k is equal to 0 indeed, else, float of negative infinity to discourage the solution and only encourage solutions that have like, exactly k elements inside of them. But we might fail one of the test cases here. Yeah, so we already failed one of the test cases here, yada, yada, yada. It's like, yeah, if you have, yeah, so like for example here, if you force yourself to pick 2 elements, that's like, okay, you can only pick these 2, which will give you a 7 total sum, right? That's kind of the idea. But here we can pick less than k if we want to, right? K is equal to 2, but here we only pick 1, which is of value 10. So in either case, even if k is not equal to 0 and I'm at the end of the array, that's completely fine. I can return 0. Okay. Otherwise, let's get the current event. So it events at index I. We're not going to need the start value, but we do need the end and values. So there's going to be 2 possible cases. Remember, we can either skip the events or we can pick the event. So the easy case is we skip. If we skip the current event, okay, just move on to the next interval, right? Move on to the next interval at index I plus 1. And we're going to say, okay, there's still k possible remaining intervals for us to pick because we didn't pick the current interval, we just skipped it. So we didn't add, we didn't select an extra interval that we can now no longer, like we can only pick up to k intervals. Since we didn't pick the k intervals, we don't change the value of k. But also here, we don't add anything to our result because since we skip the interval, we don't get its value, right? So case 1 is very straightforward. Just self.dp from index I plus 1 and the same k. We don't get any added value. We just move on to the next interval, and we keep the same k value. Now, case 2 is, okay, let's pick the current event instead of skipping it. Well, in this case, okay, since we're picking the current event, this event has an end time, right, which is dictated over here. We can now only pick intervals whose start time is larger than this end time, right? Because these intervals, end is inclusive inside of the interval. So since we want things that are non-overlapping, and that's why we sorted the events at the very beginning so that everything is in linear order when I go index by index. But now it's like, okay, I can only have intervals whose end value, or whose start value is greater than the current interval's end value because I'm picking the current interval. So I can only pick things that are after this interval's end, right? I must invest the current time inside of the current event until that event is over, and only then can I start adding events. So I can only consider events that are after the current event. So things whose start time is greater than this current interval's end time. So I'm going to say, it's like, okay, the earliest possible interval that I could do is the one at index I plus 1. I'm going to say, okay, what is still the case that index is less than n, and the event at index start value is still less than or equal to n, i.e. it still overlaps with the current interval, I'm going to say index plus or equal to 1. Keep incrementing index by 1 until we get to a point where it is the case that event at index's start value is greater than n, right? Where it is not the case that it's less than or equal to the current interval's n time, right? Notice that index might eventually be n, which dictates that there's no events remaining. But remember, we already handled the case where I is greater or equal to n, so we're being chilling about that. And yeah, but otherwise, we're essentially going to say, okay, index is equal to I plus 1. Keep incrementing the value of index as long as it is the case that the event at this index start time is less than or equal to n, right? Because if so, that means it is not after the current interval, so we can only consider events whose start time is after the current intervals and time that we are picking, which is why, again, we sorted the events in the first place to allow for this dynamic programming function. So then, once we have a valid index, right, if index is n, remember when we do self.dp of n, we'll just do 0 afterwards, right? But the point is okay, this current interval had a value. We just picked this interval, so we get its value. So case 2 will be equal to this current interval's value plus the remaining value from picking at most k minus 1 intervals now from index on forwards, right? If index is n, then I greater or equal to n will return 0 because there's no events left to pick, so we have that case handled. Otherwise, index might be some valid index, and so we can choose maybe pick that one or don't pick that one and so on. But the point is we'll keep on doing this problem recursively, so self.dp from index, but now we also subtract k by 1 since we just picked an interval, so that means that's one less interval we can pick in the remaining dynamic programming calls. So that's why here we pass in k minus 1 instead of k as we did in the first one where we skipped the event. And that's it. So case 2 will be the value of the current interval plus the remaining value from the first valid index, right? The first index whose start time is greater than the current picked interval's end time, so that we have nothing that's overlapping, with k minus 1 in the second parameter to dictate, hey, we just picked an interval, so now k is 1 smaller, right? And remember, at any point if k is equal to 0, we return 0 because it's like, hey, we pick k intervals, we can't pick anything else. So then we have the only two possible cases, right? The value in the case where I skip the event and the value where I include the event. So it's like, okay, let's keep the bigger one of the two, right? Whichever one has maximal value because we want the maximum sum. So choose case 1 if it is the case that case 1 is bigger than case 2. Otherwise, it means that case 2 must be greater or equal to case 1, so pick case 1, right? This is the same thing as saying res is equal to max of case 1 comma case 2, because the max function is kind of slow in Python, so I tend to like writing it like this. This is like Python's way of doing ternary operators. Kind of ugly, but it is what it is. Then remember, we cache the result in case we come through this subproblem later, return res, and there we go, bada bing, bada boom. We can submit one last time, and as we can see, we have a nice and efficient solution to this problem. We're kind of like right dead center inside the standard deviation curve. We can submit a bit of times. We'll move around there. I don't know what people did to be inside of this standard deviation curve. Maybe there's a little bit of O1 stuff you can do. Oh, maybe they did this problem like by doing bottom-up dynamic programming instead of top-down dynamic programming. But at the end of the day, it's probably going to be an O of n times k solution anyways. So I'm not going to be too worried about that. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and enjoyable form, I'd highly appreciate if you left a like or a comment. Otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.